Let us now look at yet another question of the IIT JEE 2017 advanced paper. The question says, if 2x minus y plus 1 is equal to 0 is a tangent to the given hyperbola x square upon a square minus y square upon 16 is equal to 1, then which of the following statements cannot be true? That is, which of the following cannot be the sides of a right angle triangle? So, we have been given a hyperbola x square upon a square minus y square upon 16 is equal to 1, and we've also been given the equation of a tangent to this hyperbola. The equation is 2x minus y plus 1 equals 0. And so for these given conditions, we have to check which of these three sides given to us cannot be the sides of a right angle triangle. So, for instance, in the first option, we have 2a as one side of a right angle triangle, 4 as another side of right angle triangle, and 1 as another side of a right angle triangle. So, if we assume that each of these represents side of a right angle triangle, then we have to check for which of these 4 options these 3 given values cannot represent the sides of a right angle triangle. So, let's get started. Well, we know that this line is a tangent to this hyperbola, and so to find the point at which this tangent meets the hyperbola, what we do is we solve these 2 equations simultaneously. So what we do is we realize that 2x minus y plus 1 is equal to 0, and so we can now substitute the value of y. So we can replace y as 2x plus 1. So I will now write, because 2x minus y plus 1 is equal to 0, I can now substitute 2x plus 1 in place of y. So y has been replaced by 2x plus 1. And this replacement will be done in the equation of the hyperbola. So now I will get x square upon a square will be retained. Then I will have minus of y square upon 16. But y we have seen is equal to 2x plus 1. And so we can now replace y by 2x plus 1. So this becomes y square, that is 2x plus 1 the whole square upon 16. And plus, or rather this is equal to 1. So this is also retained. Now note that in this case, we've been doing this replacement, and now we have to solve this equation and find the value of x. Now, to solve this equation, we will realize that this is a quadratic in x, and so if we try to solve it, we will first have to equalize the denominators. So we will now get 16x square minus a square into 2x plus 1 the whole square is equal to, now this LCM of these denominators becomes 16a square, which when goes on the right hand side becomes 16a square in the numerator. So we now obtain this kind of an equation. Now note that if we solve this further, then we will get 16x square minus a square multiplied by expansion of this will be 4x square plus 4x plus 1 should be equal to 16a square. Now to further solve this, note that if we take the x square terms together, then we will get x square out of the bracket, and inside the bracket we should get 16 minus 4a square. So this becomes the bracket containing the x square term. Let us now look at the x term. Now the x term here simply has a minus a square multiplied by 4 as the coefficient. So we will write minus of 4a square into x. And then we will combine the rest of the terms, that is the constant term, which in this case is minus a square minus 16a square, which becomes minus 17a square. And this will be equated to 0. So we have now obtained this quadratic equation, which should give us 2 values of x. So now to solve this quadratic, we should get 2 values of x. However, note that these values of x are the values of x coordinates of the point of intersection of this tangent and the hyperbola. And clearly, because this line is a tangent to the hyperbola, it will always have one and only one point of intersection, which means that this quadratic equation will have the same root. That is, one root will be repeated, and so 2 distinct roots will not be obtained for this quadratic equation. And so the condition wherein if we have a quadratic equation, then suppose we have a quadratic equation of the form ax square plus bx plus c is equal to 0, and suppose such a quadratic equation has 2 equal roots, then in that case this should imply that b square should be equal to 4ac. So the condition for quadratic equation to have equal roots is that b square should be equal to 4ac. In our case, our capital B is minus of 4a square. So if we replace capital B by minus of 4a square, we should get 16a to the power 4. Now, b square has been written and on the right hand side we have 4 into a into c. Now, our capital A is the coefficient of x square, which is 16 minus 4a square. So here I will replace capital A by 16 minus 4a square, and similarly capital C will be replaced by minus 17a square. So here I will write minus 17a square in place of capital C. Now note that here this 16 will cancel out this 4 and this 4 here, and so we will be left with a to the power 4 is equal to 4 minus a square as the first bracket, and the second bracket will be minus 17 a to the power 2, that is minus 17a square. Now, to further solve this, I can rewrite this as a to the power 4 is equal to 4 into minus 17 becomes minus 68, which will have the multiplier a square as well, and the second term will be minus into minus, which becomes plus, and so we get a 17 into a to the power 4. Now when we rearrange this, we should get the value, or we should get the equation. Note that firstly a square is not equal to 0 as we are assuming, then we now get a square minus 17a square becomes minus 16a to the power 4, and this will be equal to minus 68a to the power 2. Now this will further imply that because a square is not equal to 0, we can now write a square is therefore equal to 68 by 16. Now 68 by 16, now if we divide 16 by 4, we get a 4 in the denominator, and if we divide a 68 by 4, we get 4 ones are 4, that is 1 here, and then we get 7 here. So we get 17 upon 4 as the value of a square. So having obtained the value of a square as 17 upon 4, we can now easily deduce that therefore a is under root of 17 upon 4, which becomes under root of 17 divided by 2. So this is the value of a that we have obtained. Now note that we have to check for this value of a, which of these options represents the sides, or rather which of these options does not represent the sides of a right angle triangle. Now if you take the first case, that is 2a, 4 and 1, so if these are the sides of a right angle triangle, then if you take the value of 2a, so here we have obtained that a square is 17 upon 4, and so if we write 2a square, 2a the whole square is now equal to 17. Note that here a square was equal to 17 upon 4, because of which we took this 4 on the left hand side, and so we obtained 4a square is equal to 17. Now 4a square is same as 2a the whole square, and so we've obtained 2a the whole square is equal to 17. Now that we've obtained 2a the whole square is equal to 17, we will realize that if this is the hypotenuse of a right angle triangle, then we will have the hypotenuse measuring 17 units, or rather the hypotenuse square will be 17 units, and so the other two sides are 4 and 1, and so if this side is 4, the square of this side will be 16, and if this side is 1, the square of this side will be 1 itself, and so we will write hypotenuse square will be equal to side 1 square plus side 2 square. So in this case, because we have 17 is equal to 16 plus 1, we can write that this is a right angle triangle, and so for these values we get a right angle triangle. So this is an option in which these three sides represent the sides of a right angle triangle, but we want the sides that cannot be the right angle triangle, or rather we want those options in which the sides cannot be the sides of a right angle triangle, and so this is rejected because this does form a right angle triangle, and we want options in which the sides are not forming a right angle triangle. So let's look at option B. Well, in option B, if you find out the value of a from here, you will get a is equal to under root of 17 by 2. Now, under root of 17 comes something close to 4.123. So under root of 17 takes the value 4.123, that is very close to this value. And so if we find under root of 17 by 2, which is the value of a, then we should get a therefore is equal to half of this value, that is 2.0615. Now, so if a is equal to under root of 17 by 2, then we can write a as 2.0615. Now, if we take the value of a as 2.0615, then for these values, we do not get a triangle in the first place, because for a triangle, the sum of lengths of any two sides has to be greater than the length of the third side. In this case, if we take the first side as a and the second side as 1, then a plus 1 will be less than 4, and so we cannot have this forming a triangle in the first place. So this does not form a triangle, and so this is an option in which the given values cannot be the sides of right angle triangle. So this is one of the options that we will consider in our answer, because we want the option that cannot be the sides of right angle triangle. Similarly, if you look at the other option having the sides a, 4 and 2, you will realize that because a is 2.0615, this again cannot be the sides of a triangle in the first place. So these three sides cannot form a triangle because the sum of lengths of two sides is, in this case, so for assume that in this case, if our a is equal to 2.0615 and our other sides are 4 and 2, then this will not give us a triangle in the first place, and so this again becomes a possible answer. In the third case, we have options 2a, 8 and 1, and if you take the value of 2a, which here will be, 2a should be now equal to 4.123. Next, we have other values as 8 and 1, so we have the other side as having the value 8 and the third side as having the length 1. Now, if we have a triangle forming these three, or a triangle formed by these three sides having lengths 4.123, 8 and 1, then again this will not be a triangle in the first place because the sum of lengths of these two sides will be greater than the length of the, or rather less than the length of the third side, and so we will not have a triangle in this case. And so again this is a possible option because we want options in which these three values do not form a right angle triangle. So to revise, in this first case, we found that this formed the sides of a right angle triangle, so this was discarded. Next, we saw that this did not form a triangle at all, and so the question of right angle triangle does not arise, so we accept this option. Similarly, in this case, a, 4 and 2, so when the sides are having the length a, 4 and 2, you will realize that in this case, these do form a triangle, but these do not form a right angle triangle, because for a right angle triangle, the hypotenuse square should be equal to side 1 square plus side 2 square, which is not satisfied, and so this also becomes an option. So now we have the final answer as, out of these four options, we have option B, option C and option D as not representing the sides of a right angle triangle, and so the answer to this question is option B, C and D. So we take these three options and our question is solved.